2019-2020 academic session, physics practical 1 questions. Instruction: answer all questions. These are mostly subjective questions. You have 20 questions for an hour. All right, name, matric number, department, blah, blah, blah. Question 1. Hold on. Some of them you don't, I'll take the one for you to copy and one for you to leave. Is that okay? Don't write all. For this one, just listen, don't copy. Listen, it says, a measurement is said to be dash if it is close to the actual value. What's the answer? Accurate, that's all. Number 2, what are the measurement accuracies of I meter rule? Meter rule: 1 millimeter. Vernier caliper: stopwatch. Stopwatch: 0.1 second. You can write that one there. Stopwatch: 0.1 seconds. So stopwatch reads 0, 0.1, 0.2, right? So I think I didn't give that one. So the answer is 0.1 seconds for stopwatch. You can see it's actually simple. Well, it gets complex as we go down though. All right. Write this one down. Write this one down. 4 students each make a series of measurements. 4 students each makes a series of measurements of the acceleration of free fall, of the acceleration of free fall of the acceleration of free fall, comma g, as shown in the table below. As shown in the table below. Use the information to answer question 3 and 4. Use the information to answer question 3 and 4. All right. So you have the students, 4 students, and their result. Please copy down. Let us proceed, please. All right. So the question talked about the results of 4 students trying to measure the value of gravity G. So students A, B, C, D, 4. You can see their values. Question 3 says, which of the results is precise but not accurate? A, B, C, or D? Please check well. Which of the results is precise but not accurate? Let me remind you, we said for accuracy, the result must be close to what? The actual value. For precision, we say repeated measurement must have what there? Similar answers. All right. So 3 says, which of the results is precise but not accurate? Which of them? D. D is precise but not accurate. Why? If you look at the values of D, they are almost the same thing. But then it's not accurate. Why? It's not close to the real value. What's the real value? We are trying to measure G. That's what there. Acceleration due to gravity. What should be the real value there? 9.81. You can see this is not 9.81. So it is not close to the actual value. So hence, it is not accurate. But then there's a precision, because as I keep doing the measurements, the values are very much similar. The answer is D. Number 4, which of the results is precise and accurate? Which is precise and accurate? A is precise and accurate. You can see it's close to this, and they are also close to each other. The answer is A. All right, that one is passed. Number 5 says, don't write, just hold on. I'll tell you to write. Number 5 says, the notation this is used as an abbreviation for a certain unit of time. What is the name and value of this unit? Simple. Microseconds. All right. Name and value. What's the value? Very simple, some please. All right. 6. All right. Take this one down. 6. Take this one down. Which product pair of metric prefixes has the greatest magnitude? A says pico times mega. B says nano times kilo. C says micro times giga. D says milli times tera. All right. Which of the product pair have the greatest magnitude? All right, let's get this done, please. Pico is what? Pico. 9 is take down. The different prefixes include take down. Different prefixes include number one, tera, T, that's the symbol. You can say prefix, symbol, value. Tera is 10 to the power 12. Number 2 is giga, capital G, 10 to the power 9. Next up is mega, that's capital M, 10 to the power 6. Next up is kilo, that's K, 10 to the power 3. Next up is milli, that's small m, 10 to the power minus 3. Next up is micro, that's mu, 10 to the power minus 6. Next up is nano, that's small n, 10 to the power minus 9. Next up is pico, that's small p, 10 to the power minus 12. All right. There's femto, there's atto. So please go look for more. But these are like from plus 12 to minus 12. That's it. There's still femto, there's atto. So you can go and find these ones too. For minds, let's now answer the question. Taking this off. All right, back to this. Pico is what there? times mega. What do I have there? All right, minus 12 plus 6 is minus 6. Nano, kilo, minus 9 plus. All right, so minus 9 plus 3 gives you minus 6. Micro, giga, minus 6 plus 9. All right, finally, milli times tera. That's equal to what there? The answer is milli and tera. The answer there is milli and tera. It has the highest magnitude. That's 9. So minus 3 plus 12 is 9. You have this. They can still ask you, which of the following is the same as a giga? Which of the following is the same as a giga? The answer is milli and tera. It gives you giga to power 9. They can ask you, which of the following is the same thing as a kilo? The answer is micro and giga, the products. So anyhow they want to play with it, just know what each of them stands for and how you can manipulate it. They can still ask for division. Which of the following pair of division? They'll say milli over tera, milli divided by, let's say, micro. For instance, milli over micro, what do you get? That becomes 10 to the power minus 3 divided by 10 to the power what there? Minus 6. If I'm dividing, what do I do? So this is something that's saying 10 to the power minus 3 divided by 10 to the power minus 6. And that's equal to shift as numerator 10 to the power minus 3 times 1 all over 10 to the power minus 6. They're the same thing. I just shifted this. This is now equal to 10 to the power 3 times, to eliminate, what do you do there now? Put a minus. 1 over 2 is equal to 2 to the power minus 1. To eliminate this, add a minus. In the same way, to eliminate this one here, I'll add a minus. So it becomes 10 minus the power here, minus 6. So hence it becomes equal to 10 to the power 3 times 10 to the power minus minus plus. Minus 3, please. Thank you. All right. So it becomes minus minus plus 6. Now you see 10 to the power what there? 3. So please see the way you play with this. They can ask you for division instead. Know how to play with it. Number 7 here says, if you want to write down, no problem. Internal and external diameter can best be measured using what? Vernier caliper. Please note it, please. Internal and external diameters can best be measured using vernier caliper. Check, I said vernier caliper is used to measure wire, Abi? Yes, wire. I check it in your note, I told you to measure wire. It's also used to measure internal diameter. They said which of them is best used to. Vernier caliper is much more preferable than micrometer screw gauge. So the answer there is vernier caliper. What you can take down? Number 8, right? Number 8. Are we together? Can I start? What measuring instrument works on the principle? What measuring instrument works on the principle that provided its elastic limit is not exceeded, its extension is proportional to applied force? So it's not like saying which instrument works on Hooke's law. That's Hooke's law. Yes. So which instrument? It's not hard for you to know. The first that comes to mind is what? Spring. Abi? So which instrument is spring? Spring balance. The answer is spring balance. Simple. The stuff is simple. The simple question is this: what instrument works on Hooke's law? The answer is spring balance. Hooke's law now, provided elastic limit has not been exceeded, the extension is directly proportional to what? The applied force. That's Hooke's law now. Take this one down. Number 9. Number 9. In a simple pendulum experiment, number 9. In a simple pendulum experiment, if the time taken for 20 complete oscillation is 23 seconds, If the time taken for 20 complete oscillation is 23 seconds, what is the frequency of the oscillation? What is the frequency of the oscillation? Know the formula that frequency is equal to number of oscillation all over period. Please know this formula, please. Frequency is equal to number of oscillation all over period. Please check. How many oscillations there? 20. What's the period? 23. All right. So you have 20 oscillations in 23 seconds. Please give me value. 0.87. Frequency in hertz. So that's your answer, please. So please note that frequency is equal to number of oscillation all over period. Number 10. Right, it's a bit lengthy, so copy fast, please. Question 10. Please check your work, please. You said, when a cantilever of breadth B, length L, and thickness W is bent under the weight of a mass to the free end and displaced by a distance y from its normal position, M and Y are M equal to Y into BW cube E all over 4GL cube. All right. So M is equal to Y into BW cube E all over 4GL cube. Cube, nice on the board, cube. What physical quantity is represented by the variable E? What physical quantity is represented by the variable E? What's your answer? Think now, think E. Young's modulus. You have known now, Young's modulus E is equal to what there? Stress all over what? Strain. It's E now. Capital E. This one here. The answer is Young's modulus, please. Yes. All those long thing, no? All those long thing. The answer is what? In fact, it's not just Young's modulus, but what there? Young's modulus of elasticity. That's like the proper way. So not just Young's modulus, but what? Young's modulus of elasticity. 11, don't write, just listen. 11, don't write, just listen. It says, whenever possible, while plotting a graph, the dash variable should be plotted on the x-axis, while the dash variable should be plotted on the y-axis. Which one for x? Independent for x. For y? All right. Number 12. The diameter of a pendulum bob. Write down, please. The diameter of a pendulum bob is measured several times and the results are found to be All right. And the results are found to be all of those stuff you see there. 2.20, 2.20, 2.15, 2.20, 2.10, 2.50, 2.16, and 2.18 cm. What is the mean diameter? Please give me your answer, please. What is the mean diameter? Please get me your answer. Mean diameter is simply this plus 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 this all over how many? 1, 2, 3, 4, 5, 6, 7, 8. All over 8, please. What's your answer? So add this one there, the total sum, add them, divide by 8. Please confirm your answer. What do you have? 2.21. 2.21 units. Yeah. All right. So 2.21 here. All right. Question 13. Please check your question. Question 13. It says, a micrometer screw gauge is used to measure the diameter of a copper wire. The reading with the wire in position is shown in diagram 1. That's this. The wire is removed and the jaws of the micrometer are closed. The new reading is shown in diagram 2. That is this. What is the diameter of the wire? So how do you get that, man? What is the diameter of the wire? Of course, look up. This is when we take measurement. This is when we close it. At this point here, you can see that this micrometer is screw gauge is not very good. It has instrumentation error. As you can see, it's not in perfectly zero. That's this zero error which we discussed earlier if you're here in class. But then the idea of getting the diameter of the, look up, the idea of getting the diameter of the wire will be simply the value here minus the value here. That's all. Value here minus value here. So let's read that value, please. In this case, what's your answer here? 3.5. Huh? 3.5. Cannot be 5 now. See 5 here. 0, 1, 2. Abby? Yeah? So 2 point what? 6. We can take, no, we can take 6. 2 point, is it 6 exactly? If this is hold on, if this is 5, would this be 6 or 7? Okay. 2.60, Abby, plus 5. Question 20 says, the following readings were obtained in an experiment. You have this table. A says, using a suitable scale, plot a graph of P against R. Plot a graph of P against R. Full stop. B says, estimate the slope of the graph. B says, estimate the slope of the graph. C says, if P and R are related by the equation P equal to A squared R. If P and R are related by the equation P equal to A squared R, determine the value of A from the graph. Determine the value of A from the graph. Please get out your graph sheets. First things first, notice that there is no negative values, so hence my graph would go, graph of P against R, okay, graph should go Now listen up, listen up, listen up, listen up. So we said for a graph of, listen, for a graph of A against B, or perhaps A versus B, this one that comes first should be on the y-axis. The one that comes first should be on the y-axis. In the question, we're asked to plot a graph of P against R. P comes first, so P has to be on the y-axis. So how do you know which should be on the y-axis, that's vertical, and which should be on the x, that's horizontal? The one that comes first is always on the vertical. So this becomes P. Of course, put the units there in volts. The second man here is R, of course, in amp. So I have this. That's the first task. When we started the class today, we said our very first thing we did was what? Graphing. Check your first note today. And we said a graph must contain what there? Two very important things. What and what? Title and what again there? Scale. For your title, listen, for your title, it's always as simple as graph of this against this. So please, at the top of your graph there, you now write graph of P against R. This is the title of the graph. Please, it's as simple as this. So just graph of the first quantity against the second. That is it. Use pencil inside graph sheet. Use pencil, use pen outside graph sheet. Anything I want to write outside the graph can be in pen. Anything inside the graph must be in pencil. Common errors that I've always observed over the years. Number one, people don't buy correct graph sheets. Most persons will just rush and come into school that day, and they'll not care to get a graph sheet outside the school. You rarely see a correct graph sheet inside the school. So those of you that bought inside the school, look at your graph sheet. Observe that your markings are not the same. Some boxes are bigger than some. Check. Can you find it? Look at it carefully. Some will be okay, but those of you that bought inside school, check. Some are bigger than some. Any graph like that? Yes. With that kind of graph, you are already disadvantaged. I'm telling from my experience now. This one is not on Google. From my experience now. Most of the graph sheets inside school are not correct. Now listen. In other words, before your physics exam, it is expected that you should have gone outside school, buy good graph sheet, file it somewhere, and then come with it, please. All right, that's number one. Number two, this is what I can recommend to you. Please. Okay, good. That's it. Please don't use this kind of graph. Don't use this one. You can see how big this thing is. This one will give you confusion, especially when you come to taking skill. Try to avoid this. I know I'm telling you from experience. Don't use this kind of graph. This one that's like is 2 instead of 1. It can easily cause errors. So please avoid this kind of graphs. This ones. Get this one. You can see how slim it is. And also, listen, also buy a light graph. This one is light. Some of you, your graphs are so thick that you have to use crayon to draw on it before it shows. Check. Some of you, you know what I'm talking about. Look at how light this graph is. So if you just draw small pencil, it will show. And then so listen up. Let's proceed. I'm saying this thing here so that you pick out the lessons. That's one side. That's one side. So that's for the graph. I said, please look for a good graph. 1, 1, not those 2, 2. I'll show you before. Get it outside, file it inside your notes, and come to school with it. Also, when you go to the exam hall there, make sure you go with like 5 pencils. Go with 5 pencils. What I do is I'll go with 5 pencils. I'll sharpen the top and the bottom. Top and bottom. Why? No time to look time. I'm drawing the stop breaks. Switch it over. Sharp, sharp. You're going. You have to exercise your own. Some of you will not sharpen inside the exam hall. Don't start sharpening your pencil inside the exam hall. You don't have the luxury of time there. So your mind should just be alert. Let me give people there. Just fire down. No time. Fire down. What do you need 5 pencils for? The idea is simple. This is cool. Some person when they come to write physics, even pen they will not carry. It's inside exam hall. They say, I beg give me pen. They put like that. Not even talk about pencil. Pencil that one is just far from them. At that point, I'm telling from experience now. Your neighbor there will start saying, "Please give me pencil now," and then they'll say, "I'm in the pencil." Now say, "Okay, you don't want to give me, Abi." Then start quoting scriptures for you, making you feel guilty. They just tell you, "See this way, cannot even help me. A friend in need is a friend indeed." You know all this kind of stuff. They start telling you there. So carry like 5 pencils. It doesn't cost much. As you come, give me now, give one. Give me now, give one. Give. By the time, hold on. By the time you give like 3 pencils already, even if they ask you, you don't give. They'll be like, "Oh, but don't give 1, 2, 3." Like, okay, you don't try, right? So that's how to escape that mental guilt. Finally, when you're sharpening your pencil, I say sharpen it outside, not inside. When you're drawing graphs, your pencil should be go and sharpen pencil, sharpen it outside, make sure it's this. Some of you will carry your pencil inside the exam, but you don't sharpen it. The way you sharpen it, and you'll be eating it. Such that after sharpening the pencil, instead of having this, you now start having something like this. This one here. And somehow, no, you will see something that day. And somehow, your mind will be telling you that this thing here will give you a straight line. And wondering why you have ruler like this, and those guys give something like this. Don't say I did not tell you. Sharpen this stuff. It is Monday. Usually, physics usually a Monday. I don't. Physics is what day? Monday or Tuesday? Monday, Abi. It's always like it's almost always Monday. So that Sunday, sharpen everything. Keep it there. Arrange math set. Come to hall. That's it. All right. I've gotten my title. My next stuff is scale. Look up, please. How do I scale my work? Look up. How do I scale my work? The idea of, listen, I'll explain this one just now. In the second graph, I'm not explaining again. I'm assuming you know it. So listen now. How do I scale this work here? I'm plotting P against V. I said the first one will be here. So first one will be here. Second one here. How do I scale this? My maximum value is 4.6. So let's say I have these markings. The markings there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now look up, please. My highest value is 4.6 for P. So let's say I'm taking here as 1, 2, 3, 4, and 5. Listen. For P, I'm taking 1, 2, 3, 4, 5. Here becomes 5. Observe that my maximum value is 4.6. 4.6 will be somewhere here. That means whatever point I'm picking will just fall within here. But then I have enough space. So what do I do then? I'm using from here. This is 0, of course. 0, 1, 2, 3, 4, and then 5. If I take this will be okay. I can get this is 4.5 center. 4.6 will now be something slightly above the center. But then if I joke like this, what about the space? I'm wasting space. So in other words now, I use 1 to 1, like from here. 1, I call this 1. Let me see if I can use 2 to 1 instead. So I'll come here now, and this is how scaling works. I'll come here now, and instead of taking 1 to 1, I'll now count 2 as 1. From here, 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 4, 1, 2, 5, 4.6 will now be somewhere here. I've gotten much more space to work with. So this is how scaling works. All right, if you're done, please scale your p-axis, please. Scale your p-axis, please. We know that this is 1 to 1, but observe that my values are in 2 decimal places. So I will write what there? 1.00, 12, 2.00, 12, 3.00, 12, 4.00, 12, 5.00. So look up, please. If they say 1.50, that's 1.5. This is 1. This is 1.5. I can easily get it. So please scale your graph, please. I'm coming. Let me come and check them. My next task is to plot the R. For R, my maximum is 0.92. So let's say I have these markings 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and whatever. Look up. What will be calibration here? 0.1. Okay. Please, the highest is 0.9. Listen, this is not up to 1. This is not up to 1. So I'm using 0.1 instead. So from here, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. So it's more like saying it all falls in between here. But then I still have this space. So let's see if I can use 2 to 0.1. So from here, 1, 2, 0.1, 1, 2, 0.2, 1, 2, 0.3, 1, 2, 0.4, 1, 2, 0.5, 1, 2, 0.6, 1, 2, 0.7, 1, 2, 0.8, 1, 2, 0.9. Yeah, so it can work. So instead I'll come here, I'll say 1, 2, 0.1, 1, 2, 0.2, 1, 2, 0.3, 1, 2, 0.4, 1, 2, 0. Please find for your own self, please. 1, 2, 0.6, 1, 2, 0.7, 1, 2, 0.8, 1, 2, 0.9. Have R in arms. Please get for yourself, please. It's okay, look up. All right, next task will now be easy. P 1.5. That should be between 1 and 2. This 1.5. 1.5 to R is what there? 0.3. So 1.5, 0.3. 0.3 going up, 1.5 coming this way. Look for where they intersect and put your points there. Put your points there. I've got my first point. 2.5. This is 2. This is 3. 2.5 is midway here. 2.5 somewhere here. And 0.52. This 0.5 here should be 0.55 before 0.6. So if I'm looking for 0.52, how do I get that? Look up, please. This 0.5. This 0.6. Here will be 0.55. Let's say 54. Let's say 53. Let's say 52 and 51. So 0.52, I'm assuming to be here. But please check your graph sheet and make sure you're getting the correct thing. Get your 0.52. 3.3. 3.3. This is 3.0. This is 3.5. 4, 3, 2, 1. 3.3 should be here. This 3.3, this line here, 3.3 goes together with 0.66. So 0.6, 65, 66, 67, 68, 69. So 66 is here, this one here. What is this one here? This. All right. Next up, 3.90. 3.5, 3.6, 3.7, 3.8, 3.9, 3.90, 0.8. So 3.90 somewhere here, 3.90 somewhere here, and then 0.8 somewhere here. So I have this one here. Okay. 4.3, 0.86. This is 4. 4.1, 2, 3, 4, 5. 4.3 here. 4.3 here. And then 0.86, 0.5, 6, 5, 5, 5, 6. 0.85, 86, 87, 88, 89. So 86 should be somewhere here. Okay, 0.86. Finally, 4.6, 4.5, 4.6, 7, 8, 9. 4.6 is somewhere here. 4.6 somewhere here. And then 9.2. So this is 9. This is 9.5. 9.1, 2, 3, 4. 9.2 is here, somewhere here. All right, to make my graph sheet, okay, this one's okay. So please, on your own, please pick out your points. Please help if you're not sure, ask your neighbor, please. So we save time, please. See how you can pick out each of the points, please. I'm done picking my points. You pick your points, please. Now listen. I've got my title. Listen, please. I've got my title, graph of P against R. I've not done scale. What's the scale for this? Now listen. This is not 1 cm. This is not 2 cm. This is 1 unit. So the scale for my own here, scale used, what do I say here? Let's what? From here, this is 1, 2. It's not 2 cm, it's 2 units. So, let 2 units represent what there? 1.00 what? Volts on the P axis, and from here 1, 2, and let 2 units represent 0.1. 0.1, the unit is amperes on the R axis. That's it, please. Listen again. Look up, please. Look up. The major thing here is this. Listen. From here to here is not 1 cm. I used to say 1 cm. It's not 1 cm. It's what there? 1 unit. Now imagine this. Look up, please. Imagine this. Imagine if I call here. Listen. Imagine if I'm plotting, let's say this distance, and I have P in, let's say, decimeter, for instance. If you use cm, now what will be your scale? You now say, let 2 cm, now listen to that English now, let 2 cm represent what there? 1.00 decimeter. How is this possible? How can 2 cm represent 1 decimeter? It's a popular error in quotes that if you look at most persons, right, they like using 1 cm. The idea is this: it's an error that just escalated. It's not 1 cm, it's 1 unit. Why do they use it as 1 cm? If you place your meter rule on your graph sheet, it is correct. Measure distance from here to here. The distance here is what? 1 cm. And that's how the whole idea of let 1 cm, right? This distance here is 1 cm, but then you don't call it 1 cm. It's actually 1 unit. So please, take note, please. It's unit, not cm. All right, please join this. You have a straight line, have you? So please photograph, please. You have a straight line. Look up, please. Most of them may not enter. In your own, all of them can enter, but check. In your own, most of them should connect, please. This is a board drawing. So please pardon me. Check in yours, most of them should connect. Most, even if not all, most of them should connect. If yours all enter, thumbs up. We've gotten our graph and our scale. What's the big part, please? Slope. We can do slope, Abby? So look up, look up, look up. Listen. I will not move around. So listen. Here's how to get slope. Look up, please. Here's how to get slope. I think the easiest way to get slope, listen up. The easiest way to get slope is this. If this line, if it cuts through this line, you can pick it as a point. Let's say for mine now, it cuts through, look up, it cuts through this one here, and this one, it didn't really cut here, it's not perfect. This one, it cuts here perfect. So I can take here and here, from here, draw a straight line down, like this. From here, draw a straight line down, like this. So the simplest idea about slope, look for the one where it cuts. Right, pick a point there and pick a point there. I think that's like one. But listen, here's the real idea of getting slope. Look up. Here's the real idea of getting slope. Listen, oh. This is the real idea of getting slope. Look up. Listen. Your graph sheet is calibrated like this. You have vertical lines like this, and then you have horizontal lines like this. All right, so this is like a graph sheet. Let's say I draw a line that goes something like this. Should I extend this? I think I should. So look up, please. This is how you pick slope. Listen up. This is how you pick slope, please. So I have this line like this on my graph sheet. Look for that exact point where this line cuts. Look at this. This line here cuts these two, this and this meets at this point, and this line cuts here. I'll pick this point. I will also go there. Look up, please. Look up. I will not pick this one here because they don't meet. Come down again. Look at here again too. This one, like the corner of the box, is more like the corner of the box. If the line touches any corner of the box, pick that one there. For this one, now observe that this line touches this corner too. So I'll pick this. So my slope down becomes this, this, and this. This is how you pick slope. Like this. So this is how you pick slope, please. Where this line touches here and here. Pick your slope, please. Yes. That's because your graph is not good from the beginning. Let me see the graph. Let me see the graph. Please, who is done picking scale, please? I don't want to use bots, I want to use your own scale. Who is done picking scale? Okay. Now listen. Okay, fine. Look up. Look up. Let me use my board demonstration. I will use your value. For this one here, if I'm to pick slope, what do? Listen. My slope is equal to change in y all over change in x. That's equal to y2 minus y1 all over x2 minus x1. That's how you get slope. That's equal to, look up please, how do you pick y2? If this point intersected, I will just trace this point to my y, this point here. If I trace this for mine, I'm saying for 4 points, this is about 4.4. Please check in your table. Was there 4.4 for P? 4.3 for P? Okay, so this becomes 4.30 minus, the next one we pick is from here, trace this one downwards to here, that's about 1.50 all over. For the x, I will trace here and here. If I trace here, here's about 0.86, 0.86, that's 0.85. This one here was 0.86. Come to this point here, trace this here is 0.3. So minus 0.30. All right. If you're still confused, please show your neighbor, please. Pick out slope, please. Pick out slope. Please, somebody help me with this difference, please. This one here. 2.8 all over. This one. Please give me the division, please. What do you get? Huh? 5. Like 5? Okay. So my slope is 5. What's yours? Yours is 5 too? Your graph is not correct. Let me see your graph. No, show me from there. Let me see your graph. Is a graph the one I said you should use? Look up. Look up. Somebody just reminded me. My graph is in terms of P and R, not X and Y. So it should be changing what? P all over what there? Changing R. That becomes P2 minus P1 all over what? R2 minus, please, this. So in terms of P and R, please. That's it. Listen up. Listen up. Listen up. Listen up. Chief, I'm saying listen up now. Don't ask me, listen up now. I want to say something very vital. Listen up now. First things first, so if your lines are double lines, I think you see 2 different lines. No, just a single line. So most likely, before you draw this, your first task is to use your meter. That's why I say you have a meter rule. Use your meter rule. Just draw it faint and see if it's fine. If it's okay, thicken it. Please don't thicken at first because you might make mistake. And if the line is too thick, cleaning it will be a big problem. So first of all, before you do anything there, try to draw it, make it faint, remove it, see if it's correct. If it's correct, then you now thicken it. Avoid double lines. You do just what there, a single line. Now next up, another thing, look up. Another thing is this. Slope used to have units. Slope used to have units, and they will expect that you should know the unit of the slope. For instance, I'm seeing volts. I'm seeing amperes. What comes to mind? Ohm's law. Ohm's law. What comes to mind? You're plotting volts against amperes. From Ohm's law, I know that V is equal to what there? IR. Volts is equal to amperes times what there? Ohm. Resistance. Abi? Yes. So hence, if I plot a graph of volts against ampere, what will be the unit of my slope? Very simple. Divide here by current, ampere. Divide here by current, ampere. So if I have volts all over amperes, that will give you R, which is ohm. So therefore, the slope is equal to 5 ohms. They will expect you know this one. They won't tell you. That's it. Well, if you want to say volt per ampere, that's okay. But volt per ampere is same thing as what there. So better to use ohms. Now listen again. Listen again. Those of you that have drawn correctly, did this pass through the center? Huh? Yeah. Maybe that drew. If yours pass through the center, let me stand up. So to a great majority, please, this is just a board drawing. Yours should pass through the center, please. Right? Mine is just a board drawing. It's okay. It's okay. It's okay. It's okay. Don't worry. It's okay. Now listen up. Look up. Look up. Where's the next part there? We've done A. We've plotted the graph with suitable scale. We've done B. We've estimated the value of the slope from the graph, and we said it's 5 ohm. C says if P and R are related by the equation. So it said P is equal, they said P is equal to A squared R. Determine the value of A from the graph. How do we do that? Recall that, listen up please, how do we get the value of A from the graph? Recall that we said for a straight line graph that I gave you earlier, we said y is equal to what there? Mx plus c. What we say m is what? Your slope. C is what there? The intercept on y-axis. If I look at this now, there is no intercept on y-axis, which is in this case is your p-axis. Of course, it passes to the center. That means in this graph now, writing this graph now in terms of this, it means that P no longer Y. So P is equal to M, your slope, times X. X here is R plus C is 0. It doesn't cut the Y-axis. So I'm having this. But instead, they now said that this one here is related by what? This equation. If I compare this, we said M is equal to what there? Slope of the graph. They now said find the value of A from your whatever. This will now be P is equal to this A square now represents the slope. So hence I will have that from the graph find the value of A. So now say from the graph we will have that A squared is equal to my slope, as we said, because what is attached to R is the slope. In this one here, we use M, but in this one here, they give us A squared. But slope is equal to 5, as calculated here. So that means A squared is equal to 5. They said find the value of A. A will now be equal to the square root of 5. Please give me value. Sorry? 2.24. All right, so 2.24. That's the value of A from our calculation. So that's it. So that is very simple. Equate this to slope. You have this. So that's how we get this one, please.